So hi everyone, today we will have a lesson on the power and product rules for taking derivatives. And to remind ourselves, the definition of a derivative is the instantaneous rate of change of a function at a point or the slope of a tangent line. And at the bottom we have different notations for a derivative. Now the power rule is described as, this is just like a more formal way of describing the rule. So it's that we have d over dx of x to the power of n equals n times x to the power n minus 1, which is basically just saying that whatever function you have with the power, you bring down the power and you subtract it by 1. Now, to use it, we can use it for this example. So we can write the rule on the corner to remind us. Okay, now to apply it, we want to always write the prime because that represents that you're taking the derivative, so you won't get mixed up with any functions. So we bring down the 3, so it's 3 times x to 3, and you then subtract 1 from your power. So now you have 3x squared. So f prime of x equals 3x squared. But that's not the derivative at the point that we were looking at, which I believe was 1. So after you have the more general derivative, you can find the derivatives at one point. So you could just plug in any x value and you'll get the derivative at that point. So to get f prime of 1, we go back in and just plug in 1 into this formula. And we get that the derivative at 1 equals 3. So that is the rate at which the function is changing. Okay, so say we have a function such as f of x equals x squared plus 1 times x minus 1. To find the derivative of this function, we can apply the product rule, which is that you keep the first function, multiply it by the derivative of the second function, plus you keep the second function and you multiply it by the derivative of the first function. Now, a phrase I like to use to memorize the rule is that you keep the first derivative of the second plus keep the second derivative of the first, which I learned by Miss Mejia. So to apply this rule to this function, first we can rewrite the rule so we won't forget. Then we start by adding the notation so we won't get mixed up, and we label the parts of we want to represent u and v. Now, so we keep the first, which is x squared plus 1, and we keep multiply it by the derivative of the second, which will be, well, the derivative of x is just 1 because we bring down the 1, and if we subtract, this technically has a 1, so 1 minus 1 is 0, and the product of x to the 0 is just 1. And the derivative of a constant will always be 0, so that's just 1. Plus, we keep the second, which is x minus 1, derivative of the first, so we bring down our 2 to x, and then 2 minus 1 is just 1, and the derivative of a constant will always be 0. So that's just that. After we simplify this, we'll get that the derivative is x squared plus 1 plus 2x squared minus 2x. Now, since this is just a general derivative for the function, we could just go ahead and input our x value of 2, plug into the derivative, and that will give us that 9 is the derivative, the rate of change at x equals 2.